It's a little bit of break. I know I've been exhausting your brain power a lot. So sorry about this. Okay, so example, we maybe given 192.168.1.0. Okay. By the way, guys, I have need to add one more thing. Okay, usually for subnet mask, for example, class C 252525, okay, dot 0, usually we represent it by /24 for the subnet mask. Okay, so for class A 10.2.2.0, okay, we will put a /8. So the /8 refers to the subnet mask. Okay, to the subnet mask. Sometimes you can see okay, now we are using /8 for class A, class B is /16, class C is /24. Okay, then you will see for yourself, will it always be 8, 16, 24? No, not necessary, guys. Okay, we can have /27, we can have /28, and then /29. Okay, that will be what we call the classless or VLSM variable length subnet masking. Okay, later we will move on a bit that to VLSM, because VLSM you can create subnet from subnets that will actually better minimize the wastage of your IP addresses. Okay, then in this scenario one, we are giving this particular IP address from our ISP. Okay, of course a class C with a /24. What we are doing now is called a classful addressing. Okay, classful addressing. Okay, we will move on to classless later. Okay, classless, that means it breaks from the class already, so it's still is a class C. Okay, so basically over here we are given this IP address, and then we can know for ourselves our subnet mask is 255.255.255.0. okay, sometimes they may give you like that okay, so if it's /27, what do you think will be your subnet mask? Okay, for /24 is 255.255.255.0. Okay, because all the 24 bits are turned on. For /27, that means 24, 25, 26, 27 is making use of the last octet already. So the last octet, okay, the last octet will become what? 111.0.0.0.0. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. And then the subnet mask will not be like that. If I /27, the actual subnet mask will no longer be like that. The actual subnet mask for /27 will be 255, 255, 255. This is 24. 24 will be 24 bits will be up to here. Now we're using 27 bit, another 3 more bits. So these 3 more bits are being used. Okay, these 3 more bits are being used. What will be the decimal power equivalent? Okay, this bit, this bit, this bit. Okay, 128 plus 64 plus 32. All right, 128 plus 64 plus 32. So 128 plus 64 plus 32. Okay, our subnet mask for /27 will be 224. So it will be 255.255.255. This will be the new subnet mask if we are using a /27. Now I'm teaching you how to calculate the subnet mask. Okay, understand that? All right, because the subnet mask will be used to determine the IP packet is meant for which subnet. We may have 5 different subnets. Okay, so when we have a packet coming into our network, okay, we need to apply the subnet mask to know, so that the router will know which subnets does it belong to, so that it will route out. So it will compare it with the route table, and then it will know which subnet, and it will route out to that particular interface. Okay, so far for now. All right, so this is on a bit on subnetting classless. So let's fall back to 24. Okay, I jump a bit harder. Sorry. So let's fall back to 24. Okay, but just stay in mind how we can have 27, and then the subnet mask will no longer be like that. Okay, it will be 255.255.224. Okay, so let's move on to this. So this is right for /24. Then there will be requirements. Okay, for example, they want I want 5 departments, so they will give you create 5 subnets. create 5 subnets. Okay, and for this 5 subnet, maybe for HR, for marketing, engineering, and sales. Okay, each one of them, maybe I want how many? How many host IP address? Maybe I will take I want I want 20 hosts, 20 hosts or IP addresses. Okay, create 5 subnet with 20 hosts in each subnets. Okay, so how do I determine if it's enough? Because from this IP address, I want to create subnets now. Okay, 5 subnets. Okay, so over here, if you look at the bit from what we have, okay, I know I'm doing something which is very manual. You guys, you bring up your subnet calculator first, it will show you all the subnets already. Don't need to do until like that. But guys, in the exam, we're working on a dummy terminal. We can't even have a calculator. Okay, then in this case, we will have to do manual calculation. Okay, our subnet, we don't have a subnet calculator with us, so we can only do all this kind of manual thing. Okay, so in this case, our 192.168, okay, this is our bit 192.168. Okay, then we have a .1. Okay, which is 0.000.0.0.0.1. Okay, and then we have a 0.000.0.0.0.0. So this is the binary format. Okay, binary format for our IP address 0.000.234. Okay, all right. So this will be the binary format. Okay, now the first, remember our class C here is /24, right? /24. So the first 24 bit is the network portion. I put an N. Okay, now I need to create 5 subnets. How to create 5 subnets from this IP address given? Okay, we need to use the notation called borrow bits from host. So where is the host portion? For our class C, this is our host portion. So we need to borrow the bits from the host portion here. Okay, from the host portion here. So in this case, how many bits should I borrow to satisfy that I can create 5 subnets? So remember our power. Okay, if I borrow 1 bit, I can create 2 subnets. If I borrow 2 bits, I can create 4 subnets. Now I need to create 5 subnets. So too bad, I need to borrow 3 bits. I will create 8 subnets. So that will be enough. That will be enough. Okay, because we are not in classless, we will be wasting IP address. But that's the point right now. Okay, until we move to classless. Okay, so we're going to borrow 3 bits. Okay, 2 to the power of 3 equals to 8. So I will be able to create 8 subnets. Okay, when we borrow 3 bits. All right. So over here, all right. Then over here, okay, we borrow 3 bits. This will become tap tap tap. Okay, 1, 2, 3, 4, 5. This will be the new subnet mask. Okay, this will be the new subnet mask. So so later we will see for ourselves 255.255.255. Okay, 111. 111 is 224. 224. Okay, 128 plus 64 plus 32, if I'm not wrong. Okay, is 224. Okay, so this will be the new subnet mask if I borrow the bits. Okay, I borrow 3 bits, and then if I write in slash notation, it will be /27. Okay, it will be /27. All right, it will be /27. Okay, this will be the new subnet mask. Okay, then I will be able to create 8 subnets. Then within the 8 subnets, how many IP addresses will we be having? So we will still be having, okay, the rest of the 5 bits as the host portion. So I have 2 to the power of 5. 2 to the power of 5 is how many? 0, 1, 2, Okay, 0 to the power of 5, 0, 1, 2, 3, 0, 1, 32, 32. Okay, equals to 32. And we need to minus 2. Okay, minus 2. So equals to 30 IP addresses. Okay, 2 to the power of 5. 32 minus 2. We got 30 IP addresses available. That is also able to satisfy the 20 hosts and create 5 subnets. Okay, now we are sure that by borrowing 3 bits from the host, we can create 8 subnets, which is able to satisfy 5 subnets as a requirement. And each of the subnet will have 30 IP addresses, while we will be able to cover the 20 hosts. We can now start to write our what we call our networks. Okay, so we can have network 1, okay, network 2, network 3, network 4, network 5. Okay, then what will be our this will be the network address. Okay, this will be the network address. Okay, then this will be the first usable bit, first usable IP address, first usable IP. Then we have the last usable IP, and then we have the what we call the broadcast. Remember the broadcast IP address. So that's why we minus 2, 1 for the network, 1 for the broadcast. Okay, so over here we can start to populate this thing down. Usually in the exam they may ask you to populate all this kind of thing. Oh, okay. So what will be the first network? Over here, over here, I'm going to teach you something called what we call a magic number. Okay, so we remember here we borrow 3 bits. We borrow 3 bits here. So the 3 bits is these 3 bits. The rest are the hosts. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the first 3 bits okay, you just have to take the last digit. Maybe I put red color is better. Okay, okay, cannot. Okay, I just have to take the last digit here, okay, and then find the corresponding power of it. That is called the magic number. So over here, 1, 2, 3, okay, 2 to the power of 0 is 1, 2, 4, 8, 16, 32. Okay, this is the last bit of that borrow bit. So the magic number is equals to 32. Is equals to 32. Okay, is equals to 32. All right, so how are we going to do with that? Okay, so the first network address will be 192.168.1.0. Okay, all right, the second network address will be 192.168.1.32. The third one will be 192.168.1.64. We keep on adding the 32. Okay, this will be the magic number. Okay. And then the fourth network we created, okay, will be 192.168.1.492.3.696. Okay, 96. Okay. And the fifth subnet we created 192.168.1. Okay, will be 128. Of course, we have the 6, we have the 7 subnet, and we have the 8 subnet. But I just need the 5 subnets. Okay, so with the network address now I have okay, created based on borrowing the bits. Okay, what is the first IP address I can use? First IP address will be 192.168.1.1. Okay, the broadcast is usually the last one. Okay, so the last IP address, so the next IP address beginning is .1.32. Okay, the last IP address, okay, is 192.168.1.1. dot 1 dot. Which number do you think will be, ladies and gentlemen? Anyone help me to answer? Just to keep this
31.
session. 31. Thank you. Okay, 31. Okay, then the last usable IP address that I can assign to my computer will be 192.168.1.30. Okay, will be like that. All right. So I can continue to populate this 192.168.1.33. Okay, this one will be dot 63. Okay. Okay, your auto correct can or not? Auto correct in your brain. Okay, never mind. Yeah. It's okay. Yeah, there's a problem when teaching in this kind of home-based learning. Okay, it's best in whiteboard. Okay, this will be 62. Okay. Then this will be 65. This will be 95. Okay, this will be 94. Okay, this will be from 65, 6. This one will be 95. Okay. Yeah, 94. Okay. This one will be 97. Okay. So you go and populate all these things down. Then you get your whole 5 subnets that you can assign to your router for the configuration. And then what will be the subnet mask? Ladies and gentlemen, the new subnet mask is no longer /24, right? The subnet mask now has been changed because we borrow 3 bits, right? So it's now /27. Okay, it's now /27. And the new subnet mask is 255.255.224. And I have mentioned that the subnet mask is used to let the router determines which subnet it is, because in this kind of a scenario, okay, all right, we have a router, then we have all the different subnet. Okay, this is from .1 all the way to 30. Okay, this one is another subnet from 33, okay, to 63. Because the broadcast IP address is usable IP host. So router will have the interface connected. Okay, they will identify this subnet address that is connected to this subnet. So this subnet is 192.168.1.0 is directly connected. Okay, directly connected via this gigabyte interface. Okay, 0/0. Now, if I have an incoming packet destined for destination IP address, okay, equals to maybe 192.168.1. Maybe 100. So how does the IP know which subnet it is? So you take this, okay, 192.168.1.1. Okay, sorry. Okay, it will do a AND with our subnet mask, which is 255, and 224. And it will be able to know which subnet it belongs. Then it can route out. So let's try it out. So this will give you 192. This will give you 168. This will give you 1. Okay, 100. Binary. Okay, 1, 2, 3, 4, 5, 6, 7, missing 1. See, 1, 110001. Yeah, correct. Okay. Then over here, 224 binary. Okay. Okay. So it will end all these things together. So what do you think will be the ultimate? Okay. So I take this one, I put inside decimal 100 and with 224. Okay, equal. Okay, this binary number. All right, which is decimal 96. Okay, so they will find that this dot 100 actually belongs to the fourth subnet, to this fourth subnet. So you see, the fourth subnet starts from 97, ends with 127, last usable 126. So you see, it will give us 96. Okay, so this one is actually 96. This is the subnet. This is the subnet it belongs to. Okay, this is the subnet it belongs to. So our router will know which particular one to send. This is the fourth subnet. So this is basically subnet address 192.168.1.1.96. So the packet coming into here, after it ends with the subnet mask, it knows this is 192.168.1.96. You refer to the routing table. Okay, the routing table state 192.168.1.96 network. Okay, directly connected to maybe a gigabyte interface 0/0/1. So it will be able to pass this packet out to this subnet. Okay, guys. This is the subnetting for a very classical case. Okay, let's take a short break from here. Maybe I know a heavy one. Okay, let's take a short break from here. Maybe 15 minutes, 1-5. Okay, we come back again at 11:15. Okay, we will carry on to maybe we use another different class. After we use a different class, then we move on to VLSM. Variable length subnetting mask, or we can actually borrow this example. We go on to VLSM, then we do one example again on another class B or class A, depending. Okay, so let's take a break. Then you digest a bit for those who are not in the IT domain. This is how subnetting is being done. Okay, first of all, I clarify the bit power. Okay, then I clarify the range. Okay, on the classes, how much IP addresses and the host IP addresses we have for each classes. That will give you the amount of subnets and the hosts we have. Okay, and for each of the subnet, usually we have to -2 because one is reserved for network address, one is reserved for broadcast address. This is what you see here. Okay, that cannot be used. All right, then from there, I told you guys that there is a subnet mask involved. Subnet mask is used to find out which subnet it belongs to, so that the router can know where to route. Okay, so in this case, subnet mask usually we can write in /24, but it can also have /27, 28, 29. All right, it depends on the number of bits that we use to borrow to create a subnet. So in this example, okay, we created 5. We need 5 subnets, 20 hosts. Okay, so we need to borrow how many bits from the host portion. So if this is a class C, okay, we have the host portion as the last 8 bits. I borrow 3 bits. Why 3 bits? Because 2 to the power 3 is equals to 8. I can create 8 subnets. I left 5 bits for the host portion. 2 to the power 5, I got 32 minus 2 for each of the network and broadcast. Every individual subnet will have 30 IP addresses. Okay, then I tell you an important thing. This is the important thing here. This magical number. Okay, so from the 3 bits we borrow from the host, we always take the 1, okay, to the rightmost, okay, and then use that 1 to find out what is the power location. So in this case, we have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5. Okay, so 2 to the power 5 is equals to 32. The magic number is 32. Then with the magic number, I can start to populate the network address. First, .1.0, second, increase 32, third, 64, fourth, 96, fifth, 128. The sixth, I can add 128 plus 32 also. Okay, then from the network address, okay, I can actually determine, since the second network is .1.32, the last broadcast address of my first network will be .1.31. Then, of course, here, 30 hosts, I have .1 to .30. I can just borrow this and format it out, the host and the broadcast address for the whole 5 subnets. Okay, then with that, I show an example that if we have a packet incoming from a router, it wants to know which particular subnet it belongs to. This is where the subnet mask is very useful. Okay, so by ending with the subnet mask, since our subnet mask has been from /24, 255.255.255.0, now change to a new subnet mask because we have subnetted, okay, these IP addresses into 5 different subnets. So our subnet mask will be 255.255.224. So I actually use a logical AND. Okay, so it works out to be 192.168.1.96, and .196 belongs to the 4th subnet, which is what this IP address, okay, .1.100. So it needs to know which subnet it belongs to. So it knows that this is belonging to here, so that the router will know that this is .196. You refer to the route table. For the route table, okay, over here, it will work out .1.96, maybe going up to interface 0/gigabyte 0/0/0/1. Then it will forward to the interface. Okay, so this is in essence how a whole subnet work and how the whole IP routing, how the whole IP router knows how to route based on the route table. Okay, so coming back after 15 minutes, from here we will work out another few more examples. Okay.